Right, so my name's Jim. I'm an academic. I was going to do a demo. We'll see if there's time for that at the end, because I know Christopher Ray said he wouldn't, but we do demos sometimes. So I'm based in Sweden, and we have a data center in northern Sweden, and we are providing Spark as a service. We also happen to provide Flink TensorFlow as a service. We have about 150 users. We have our own data center. Today's our national day, by the way, in Sweden. So if you meet a Swede, congratulate them. And this actually came about because we have a project called Hops Hadoop, which is a new distribution of Hadoop. And we developed a new security model around it. And then we thought, hang on, we can actually provide Spark as a service. And Spark Streaming is one of the services we provide. I'll talk a bit about our journey, how we get there, and what we've been doing and what we find interesting. Okay. So the other thing about Sweden that's interesting is that labor is expensive, right? So if you're a cleaner or whatever, you're going to cost a lot, and sysadmins are very expensive. So we want it to be completely self-service as much as possible, as far as possible. So Obama's going to spark up by himself. Okay, so a very brief overview of structured streaming. We know that there's data being ingested into a system. It's going to come in through some pipe or ingestion. Maybe it's going to be Kafka. Maybe it'll be a file. And Spark Streaming will operate on that incoming data in micro batches. And structured Spark Streaming will take SQL in. So it's going to try and use the same logic and same APIs that you use in traditional batch Spark in order to actually operate on the data as it comes in. A couple of other things that you really need to have if you're going to provide Spark as a service or structured Spark Streaming as a service is you need to have some storage platform for your checkpoints and write-ahead log, because you want this to be highly available. And you also want to be able to inspect your job as it runs. So monitor the job. So you're going to have some kind of monitoring system in place, and you're also going to be able to read the logs, so debug your applications. So you're going to have some online logging service as well. Now, what we did in our particular platform is that we chose Kafka as the input pipe, which is pretty standard. We have our non-standard Hops Hadoop platform underneath it. We are also providing for data scientists Zeppelin and Jupyter as notebooks. And then for the monitoring, we're doing Grafana and InfluxDB. And finally, for logging, because I'll talk about it later, but one of the limitations of Yarn is that, well, we don't have support for online logs, so we need to use the Alex stack for that. Okay, so our platform looks roughly like this. You have Kafka as an input for bringing data into the system. We'll see later on, it's quite interesting, but if you have somebody external to the system that wants to ingest data, we're using certificates everywhere. So certificates will help us to allow people external to the system authenticate against Kafka topics. And if you're running in a Hadoop platform, you'll be familiar with Kerberos. Kerberos doesn't work with outside of its organizational domain. So in that sense, we like certificates in particular for structured streaming. We're running our own Hadoop platform, Hops Hadoop, and what I'm going to go through a bit today is just a little example as well of how can we write some structured Spark streaming, write to a Parquet file, and then do some basic batch analytics in Zeppelin. And then the last part was I said we need to do logging and we need to do monitoring, so we're using InfluxDB and Grafana for that, and Elastic Stack for the logs. Okay, one other point that's of interest to us in Europe is that within a year we're going to have a new law which is covering private data, and it's called GDPR. And in 1 year's time it's going to be in place and you'll have to follow it. And nowadays people are mostly concerned with Google and Facebook and what will they do, but it covers everyone. So it covers everyone from Databricks to smaller companies. So you have to be careful about how you manage your data. So one of the aspects of GDPR that's important for us as well is privacy by design, which is a principle enshrined in GDPR. So we have our own Hadoop platform. It's called Hops, and we've introduced some new abstractions. And the most important abstraction we've introduced is the notion of a project. So a project is a grouping of users and data. So if I have a number of data sources, a data source can be a subtree in HDFS, it can be a Kafka topic or a database. What a project will be is a line around a grouping of those users and data sources. And basically, that's now a unit of isolation. So those users who are members of the project can access those data sources depending on the roles they have. But basically, any processing they do inside that project will stay inside the project. They won't be able to cross-link with data sources outside the project. They won't be able to copy data outside the project unless they're given a permission to do so. So you can basically draw any lines you want around any grouping of users and data sets, and you basically get a project. The only restriction to it is that a data set will have a home project, okay? And in accordance with this GDPR principle, every data set will have an owner. So there's going to be an owner that we can say that's the person responsible for that particular data set. So I said we wanted to build a self-service platform, and we've done it by trying to use our project abstraction and say, well, how would this relate to existing systems people are familiar with? And you can take GitHub as an example. So we want basically users to be able to add new members just like they would in GitHub. And changing a role. So if you have a project and you give a user a role, we started out working with bioinformaticians, and they wanted 10 different roles. And we really tried to cut this down as much as we could. And we basically ended up with 2 roles, again in kind of accordance with this GDPR law. So we have a data owner, the person who is responsible for the data, can import and export data from the project, add new people to the project, change their roles, share data sets with other projects. And then a data scientist who's basically someone who's going to run code and applications on this platform, so do analysis. Okay, so the main point here, I guess, about this is we are now delegating administration of privileges to users. So if you're from a Hadoop platform, you'll be familiar with a lot of the kind of centralized access control platforms that are out there. Okay, we again wanted to make it self-service, so we want people to be easily able to share data. Data could be anything from a database, access to a database, or a topic in Kafka. And you can do that basically by right-clicking on a data set and then basically sharing it with another project if you're a data owner. I'm going to show an example of that later on. A final point just about some of the things that we added, again, for self-service is the real problem you have in Python. So Python is taking over a lot, but the real problem you have is how do you get your binaries out onto the cluster? So people will say you can get an egg, but that egg may have dependencies that are not included. And it's very challenging in a Hadoop-style environment to actually get the libraries you want installed on all the machines. In our case, we support Conda on every machine in the cluster. And for your project, you have your own virtual environment. So then you can install your Conda libraries for that particular environment. So you can have your own version of Python, your own version of Pandas, and your own TensorFlow version if you want. Okay, that's the kind of, I'll do a brief demo just so that you get a feel for what I was talking about here. So if you look at the screen here, you can see we have projects on the right-hand side. So projects are quite easy to create. They're quick and cheap. You can select a number of services associated with them. So that basically created a subtree in HDFS and a bunch of new things. And if I go into that project here, that we can see it now, here, I'll just make it a bit bigger. We can see that if we talk about Kafka, for example, so we want to make Kafka easy to use. So creating a Kafka topic, let's call it Databricks. I can pick a schema for it. Users don't need to talk to administrators to do that anymore. And if the user wants to share this topic with another project, the user can just click on it and share the project. So that's pretty straightforward. We have a schema registry here. Schema registries are very useful, particularly if you're working with structured streaming. So in our case, we support Avro as our default schema for topics. And so you can basically attach any Avro schema with any topic you want. Okay, I'll go back here. This one, yeah. Okay, so now I'm going to give a quick study of those abstractions and how we're using it with a company in Stockholm to support IoT platform. So their IoT platform takes in a lot of sensor data to gateway nodes, and that data gets fed into an infrastructure they currently have, and then it gets fed out to these companies who use their platform. So in this case, what they want is they want a single platform to serve lots of different companies. So we're talking about multi-tenancy in the user sense of things, rather than having multiple applications on the same platform. So multiple tenants being multiple different companies. Now, it's never generally that simple. So in their case, they have lots of customers on Windows or Microsoft Azure and Google Cloud and AWS. And they need to bring all of them together into a single platform. So their platform has to exist somewhere, and it needs to interact with all these different clouds. So one solution that you might have, if you're thinking about it as the company, you would say, well, I'm going to run on AWS. I'm going to take in the data into Kafka. I'm going to write a Spark streaming app. And I'm going to write the data to some S3 buckets. And then I'll share those buckets with the customers if they want to pay me, for example. I might decide I'll do some analytics reports and sell those reports to the companies. So the one problem about this is that either you just sell pre-packaged analytics reports or you share your data with your customers, but the company who's generating this data and managing it is ceding control of it to its customers. So we'll just see how our model enables them to keep control of the data. So what we have is we have a single Kafka topic to bring in the data and feed the data into the system. So the company itself controls that project and owns that topic. And then each company that's in the platform will have their own project. As part of that project, they're going to have a data set which is shared with the company's project. And they'll also have a topic which is shared with the company's project. So the company's application now, its Spark streaming application, can write to that topic that's owned for the company, and it can write to a Parquet data set for that company as well. And it can do this for every company who's a member of the platform. So once that's done, the company can then log into the platform. They can manage their own people who they want to give access to and how they want to give access to them. If they want, they can buy some prepackaged analytics reports. Or, more interestingly, they can do their own custom analytics. So they can write their own Spark streaming jobs. They can write their own batch applications, doing analytics on the Parquet data. OK, so I'm going to talk a little bit about some of the tooling that we added around our Hadoop platform and Spark streaming, because these are basically all pieces we needed to put together. This is what you need to get up to production standard. So I'll start out by talking about our Hadoop distribution. So our Hadoop distribution is based primarily around a new version of HDFS. It's a drop-in replacement. It's called HopsFS. So the name nodes you can scale out. You can add as many of them as you want. And the database nodes, you can get up to 48 nodes. So what that means is basically what was a single server, a single JVM application, the name node in HDFS, is now become a distributed scale-out platform. And the good thing about that is it helps us go much faster. So in a paper we had recently in Usenix Fast, so this is peer-reviewed numbers, we got 16 times the throughput with Spotify's workload, and we get up to about 37 times larger clusters. And a couple of weeks ago, we won the IEEE Scale Challenge for 2017. So this platform gives us lots of metadata, and that metadata we're using for these projects and abstractions that I mentioned earlier. So I showed you this already, the Kafka Self-Service UI. We can manage and share topics. You can also do low-level ACLs if you're interested. And you may say, well, users really want to get down and dirty with Kafka. They really want to change a lot of the low-level parameters. Well, in our experience, you can come a very long way with just allowing users to change the number of topics and then the number of partitions per topic. So if you help them to match the number of executors with the number of partitions, ensure that the data is balanced across your partitions, then fine-grained tuning you can do offline with them if they've got a job to that stage. But to get up to that stage, they can do all the work themselves. For the logging, I mentioned already that Yarn is problematic. So if you're running on Yarn as a cluster manager, it will only generate your logs when the job is finished. So it's not really any use for us for streaming. So that's why we're using the Elk stack, so Elastic, Logstash, and Kibana. And we're getting data in there by the Spark jobs writing using Log4j to a graphite. So that kind of looks like that. I can show an example later on. For resource monitoring, you want to make sure you're keeping an eye on how your job is performing. If it's going to lag in processing the incoming input data. One thing that Spark gives you is you can supply a metrics.properties file, and you can decide that the metrics for your job will be written to different sinks. It supports JMX. We're using Graphite because that allows us to write into InfluxDB and then out in Grafana. And there are a number of other structures supported. So if you're interested in your actual application, so rather than just maybe metrics related to how the JVM heap is performing and so on, you can use a structured query listener. And now in 2.2, you can actually send query progress reports to another Kafka topic. Or you can use, if you're interested in looking at all of your queries for a given Spark session, you can use the streaming query listener. And then you can monitor how they're all performing. So we're using, you basically get these nice graphs out. So you can also do notifications in Grafana. So if you need to send an email or something, then you can do that. Now, the last point, just in terms of applications we're running on top of this platform, Zeppelin allows us to, if we're, for example, using Parquet as a sink and structured streaming, we can then run a job in real time. We can even have dashboards that get updated in real time as data comes into the Parquet file. So one other point about our project abstraction, we're going to build on it with time, but right now what we do is we give users quotas. They get a quota in HDFS. That's part of HDFS, nothing new. For Yarn, we keep the metadata again in our distributed database, and we provide CPU quotas in Yarn. So when a user creates a project, they'll get a certain CPU quota. And one thing we've been playing a lot with is, well, how can we make sure that users use the cluster when it's less loaded? So what we do is we provide an Uber-style pricing model. So if the cluster is lightly loaded, the price will be low. And if the cluster is highly loaded, the price will be high. And that means that they're going to use more of their quota if they launch jobs at popular times in the day. A useful point about the quotas that at least researchers get confused about is they want to import a YouTube 8M dataset, which is 1.4 terabytes, into their project, and they think that will use up all their quota, but it doesn't, because sharing of data sets in our model does not involve copying it. Okay. So I'll move on a little bit to security, which is a kind of interesting point in how you write structured streaming applications. So we're using, there's two different models. Basically, you can go with Kerberos or with SSL TLS certificates, and we're going with certificates. So what we do is we give each user in each project a different certificate. So if you're a member of 10 projects, you get 10 certificates. And Kafka will authenticate users based on those certificates. It'll know who you are. If you're trying to write to a topic and you're not a member of the project that owns the topic, or if that topic's not shared with your project, you'll get rejected. And the way it works is basically that we have intermediate certificate authorities at each HopsWorks instance, and there's a root CA, and all the services as well, everything from the Hadoop services to the Spark and Kafka, also use certificates. So the certificates are a bit awkward, right? Because if I want to run a job on Yarn, a Spark job on Yarn, I need to get my certificates out onto all the machines. So how do I do it? Well, the way we do it is that when you launch your job, it'll go to the database. HopsWorks, our platform, will go to the database, get your certificates, get all the endpoints for all the services you're going to use. It'll start the app master in, typically we always run Spark in cluster mode. And it'll start the app master. And it'll also copy your certificates out onto the disks of all the node managers or the tasks running your job. And it'll copy them into a private local resource folder. So when you want to actually launch the job, we provide a library called hopsutil to make it transparent to you that you're using these certificates. You basically say, get me a Spark producer, and it'll give you one. But the properties file that will be embedded inside it will take into account that your certificate is on this path in your local folder. The other thing is that if you're using the schema registry, again, hopsutil will hide that for you. And finally, when you want to actually consume or produce from Kafka, Kafka will go to the database again to make sure that you have privileges to do that on the topic. So this is where the hopsutil thing comes in. So hopsutil, what it does is it's a way of simplifying programming structured Spark streaming applications. If you take the basic examples that you'll find, for example, this is taken from Databricks blog, you'll see that there's some basic parts you need to have in your applications: a query, an input source, an output sink, a trigger interval for your SQL, and somewhere to store your checkpoints because you'd like this to be highly available. But a lot of the other things that you need to have in your applications are you need to have credentials maybe for accessing services. What are the endpoints? Where's Kafka running? Where's my schema registry running? Maybe I need to write to InfluxDB or to Logstash. What about monitoring.properties file? How do I shut down gracefully my application? So we're encapsulating all this in a util library called hops util. And what it means is that if you have code like this, which has a lot of hard-coded endpoints in it, it basically becomes the following. You can see some examples on GitHub if you want to read up on how we use it. The basic takeaway here is that if you have a framework and your framework has a service registry, it knows about where all the endpoints are running, it knows about all the certificates, it knows where it's materialized the certificates to, then you can hide all that inside a nice abstraction. So your code ends up being quite straightforward. Here's a simple Spark Kafka producer. You use hops util to get job names, to get project names, to get checkpoint locations, and then to shut down gracefully. So shut down gracefully in this case means typically using a marker file and a thread which will monitor it. And the same goes for the consumer. Okay, I did a little demo, but I think, do I have 2 minutes? 5. Okay, I'll do a quick little demo because I kind of ran out of time due to our earlier events. So I think I'm logged in as admin. So I ran this example earlier on, but I'll just show you what I was going to do. So we can create jobs in here, and I have a producer job and a consumer job. And you just click your way through to generate them. We can look at the UI for them. This one is finished running. This is just the producer. It's not so exciting. But we have you can get access to both the Spark, the Yarn, Kibana, and Grafana UIs from in here. Now, the consumers is a bit more interesting if we look at the consumer's UI. So what you'll notice in Spark UI is firstly that you'll have SQL will appear here if you're using structured streaming. If you go ahead and look at Yarn, you can see, okay, this succeeded because it shut down cleanly. What's really nice with Kibana, if you're interested in Kibana, is you can, when you're doing log4j to write to your output, you can write lots of data in your messages, and then you can actually generate graphs on it here if you're interested. So you can do visualizations on it. There's a quick, simple visualization. And then for Grafana, we can see that this job was just reading. What it was doing actually was reading from a topic and then writing to a Parquet file. And then what I did over here was basically we read the Parquet file while the job is running, and then we can rerun this query to see new figures come out for the data that's written by the consumer. So if you're interested in Zeppelin, you can also write an Angular paragraph here, which will automatically redraw that and refresh it for you. Okay. Okay, so where are we at? So this project has been going on for quite a while. We have a lot of different development threads going on. So for the file system, we're working on multi-data center high availability. We're supporting storing files under 32 kilobytes in the database, so we get huge performance improvements. We have support for erasure coding. We have a nice new feature, which is 2-level erasure coding. And we also support TensorFlow and Spark, which is quite interesting, as well as native TensorFlow on Yarn. And that's enabled because we have support for GPUs as a resource in Yarn. And one thing we'll have later in the year, which will be, or later in the summer, I should say, is open data sets. So we're going to be able to share these data sets from your platform with anyone in the world. Okay, so to summarize, I've been talking about our new platform that we've been building and our support for Spark Streaming. It's called HopsWorks. Spark Streaming is a first-class citizen, and we've been building a lot of tooling around Spark Streaming in order to make it production ready. A lot of people have worked on the project. We have a bunch of users down here and developers, and that's it for now. Thank you.
Okay, so we have a couple of minutes for questions. So yeah, just walk up to one of the microphones if you have a question, and yeah, we'll get started there.
You talked about authentication with certificates. Do y'all provide any authorization once you're in?
Yes. Yeah, so it's a good question. So Clients provide the identity of the user, because in the common name for the certificate, we write the username in there. And if you go to Kafka, for example, and you try to write to a topic in Kafka, so Kafka allows you to supply your own authorizer plugin. So we wrote one that will basically go and do a lookup in the database to see if you're a member of the project that that topic belongs to, or if that's been shared with your project, and if so, it'll return correct. Now, you may be worried about performance of that and say, well, is that going to be an index scan in your database? Well, the answer is it's going to be an index scan, but only on one partition. So it's what we call a partition-pruned index scan, and they scale linearly. So we can get over millions per second on the database. So we're not worried about that.
So one of the problem in this shared data set kind of concept is like versioning. If I want to use a different Spark version than a user, how you're handling this, even the HDFS versions, and people want to do fancy things across and don't want to upgrade together. So is it container or something?
You mean versioning of data sets or versioning of tools?
Versioning of the tools itself. I want to use Spark 1.6 on Java, some other version, with Scala, some other version.
Yeah, that's a great point. So I think we have that problem solved for Python. We have Conda support. So for your project, you can have your own version of Python. You can have your own version of your own Python libraries. And that's completely separated. So you're going to have your own virtual environment on every single machine. When the job's launched, we'll use the Python path in Spark, in PySpark, to basically say, run from that virtual environment. Now, for other languages, it's problematic, I agree. But to be honest, the way we're going, Python is taking over. It's eating up a lot of the other languages
So just to reiterate, you're saying you think Python is the future?
Well, Python's, in data science, it's growing.
Thank you.
All right, great. Let's give him another hand.
Thanks.